Hey everyone, welcome back to the lecture. In this lecture, we will see about Spark WebUI. So let's see the contents of this lecture. First, we will see what is the Spark WebUI and how we can access it. Then we will see overview of Spark WebUI, its different tabs and their use cases. Then understanding the Spark application that we have developed in previous lecture with the help of Spark WebUI and how we can dig deep into the Spark application that we have designed. Then different types of Spark stages and job in Spark 2.x versus job in Spark 3.x versions. Okay, so this includes all the version after the implementation, sorry, Adaptive Query Optimizer AQE. So let's see what is the Spark WebUI. And here you can see Spark WebUI overviews Apache Spark provides a suite of web user interface to monitor the status of your Spark or PySpark application, resources, consumptions, cluster, Spark configuration, etc. etc. How you can use the Spark WebUI? If you are working on your local or standalone, then with the help of this URL, HTTP localhost on port 4040, you can access your Spark WebUI application. Instead, if you are working on a cluster, then on the driver node, with the help of what is your IP, you can access the Spark WebUI on this specific 4040 port. Okay. So what are the uh, like tabs or what are the options available in Spark Web UI? So you can see here Spark Web UI consists of the following all things like Spark jobs, stages, tasks, storage, environment, executors, and SQL. We will see all these things in details in further slides. Okay. So this is the diagram of how your Spark Web UI looks, and you can see this is your Spark Web UI. I will show you the Spark WebUI in detail as well. So let's go to our Spark application. Okay. So this is the Spark application that I have created in the last lecture, right? So you can see we have all imports, then we have created a Spark session. And here, note one thing, I have added two configuration, that is a Spark SQL adaptive query enabled, and I have it, make it false. Okay. So because of this, we can disable the adaptive query optimizer. So we can see how exactly the jobs works, because in Spark 3.0 jobs are created differently. Okay, then this is how, like, we have read the CSV file that we studied in the previous lecture. Okay, so you can see this is our CSV file, and let's come here. Here you can see after that we have repartition it, and we have performed some operations like with column, filter, select, group by, count, etc. etc. And we collected these results at the end of the stage, right? So this is the web application that I have developed in previous lectures. Okay. So now I will run this application. So I will clear all the outputs, and let's close the previous Spark Web UI that is there. Okay, so let's run the application. So I'm running all. So it is running, creating the Spark session. Now you can see Spark session is created, versions and everything is there. So you can just click on this link, and here you can see this is the your IP address at port 4040. We have all the things. Okay, so this is your Spark Web UI. Okay, so the application is running, that's why you are not able to see. If I refresh, you can see. Okay, so let's refresh the application. So, okay. So now you can see this is our application that we have run, and everything is there, right? So you can see there are multiple tabs, like this is the job tag, this is the stages, then we have details about the storage, then environments, and we have information about the executors that are available, and SQL. So if we run some query, then we can capture the details of this query in this SQL, and from here we can access the query plan as well for the queries. Okay, so let's see, this is our job tag, and you can see here like from here you can see the number of executors and total threads running, what are total jobs are failed, successful, everything, the status are provided here. So in our case, all jobs that are there, like three jobs, those three jobs are successful. Okay, so you can see if I hover on this, it will show the specific jobs, right? This is the jobs. And here you can see all our like actions are taken, and in the bottom you can see the completed jobs. This is the list of the jobs that are completed. Okay, in the stages you can see all the stages in all your jobs that are listed here, and you can access the stage for a specific jobs by just clicking on that job as well. Okay, so this is the in the stage tab you can access all this. If I click on this, you can see this is the stage, right? Stage for that specific. You can go in detail of any stages. Okay, if I click on this, you can see this is the stage and this is the detail plan of that stage. Okay, and after that the storage tag is there, and in the storage tag you can get the information about the storages of different jobs and how they behave. Okay, then environment. So your environment will consist of different types of variable and information. So you can see here it is the runtime information is there. Then Spark properties, all Spark properties are available here. You can see that we have used our master as local 3. Then after that you can see the Hadoop properties are also listed here. Whatever the Hadoop version we are using, then system properties are also mentioned, and here some class paths are also there. So from here you can access all your environment variables and everything. So if we come to executors, then it will show you the summary of your executor. So you can see active is right now 0, and you can see dead executors and all. And you can see disk, then cores, all the things related to whatever executors are available in the jobs. Okay. So in our case, we have three executors because we use local 3, right? So two executors and one driver. And here you can see the driver related details are also available here, right? So you can see here it is using 3 cores as I provided 3 in the Spark configuration. If I will show you, you can see this is the local 3. So this is your overview of your Spark WebUI, right? And from here you can see the jobs, its schedule mode and everything you can access from here. Okay, so let's go to our presentation and see what is the next thing. Okay, so this is the thing that is the in environment you can access all this environment like runtime, Spark properties, Hadoop properties, system properties, and class path that we have discussed. Okay, and this is the application that we wrote in previous, right? So this is the code for that. Okay, and this is the whole directed acyclic graph or how whole job worked in our application is here. Okay, so it has three stages. So let's try to understand how our application exactly works. So this is our application. Okay, this is our application, and now in our application you can see there are three things, right? This is our first application that we have created. Our application creates three jobs. So you can see it created three different jobs, right? So these are the three jobs that are the part of our application. So in job one, we have one stage, okay, and that stage also have one task, and that task is actually reading the data for capturing the schema of data, as we have used infer schema in our application code. Then the second job that is created with the help of that CSV method, and actually that job has one stage and that stage reads the CSV file. Okay. So as we all know, our jobs are triggered when any action is called. Okay. So if you see our code in our application, so here this is our application. So here this CSV method internally has two complicated actions. Okay, so one action is responsible for collecting the data or collecting the schema that will execute the first job, and other is reading your data that will create the second job. So job 0 and job 1 are nothing but created by this CSV method. Okay, then the third job, that is job 3, is created by your collect action. So you can see At the end, after that, this is the transformation, and this all are also transformation. But at the end, collect is the action, and with the help of this action, the third job is created. But the third job has three stages in it. Okay, one stage related to repartitioning the data, and other two stages are created based on the wide transformations that we used in our application code. So the first stage creates one job or one task that will read the data from your previous job, okay, previous data frame, and it will repartition the data in two things, okay. Then your fourth stage will take or will execute all the things or all the operations, transformations that we designed on two tasks that are the partition, okay, and these things runs in parallel. And in the last stage, it will read all the things from these two partition and count the things and give you the result what you want. So in total, we have three jobs. We have five stages, and we have almost seven tasks in our application. Okay. So let's analyze the application once. So you can see here I have provided one Spark configuration, okay, Spark SQL Shuffle Partition 2. For making applications behavior predictable, I have provided this configuration. So it will create only two partition at any stage of our job, okay. So in the third stage or in the third job, stage 3, 4, and 5, how it actually works. In the stage 3, here you can see repartition, and it will repartition the data that is already collected or read from the previous employee DF. It will repartition in two different partitions, okay. And after that, on two different partition at the same time with column, filter, and the select and group by transformations were run, right? So those transformation run on simultaneously in two different tasks, okay. Then in the group by is, you can see it's a wide dependency transformation. So we need to shuffle the data. So at this the data is shuffled, and after that count transformation is performed on the data before collecting the results at the driver, okay. So let's see how the thing exactly work, okay. So I will show you what is the job 2 means. It's indexed like job 0, job 1, and job 2. Actually, this is the third job. Okay. So how things work for this job. So stage 2 is created. Then stage 2 repartition, like it reads the data from previous read data frame. Okay. Then it will repartition that data. It will repartition in two different partition, and it will store the data in write exchange or in the exchange. Okay. Then after that, you can see the stage 3 is there. Stage 3 starts. In the stage 3, it will read the data from the write exchange to read exchange. It is reading the data, right? After that, it will create two tasks. And here you can see the first transformation with column that is applied. Then after that, select transformation is applied. Then filter. Then group by transformation is applied. But group by is a wide dependency transformation or wide transformation. So we have to shuffle the data across the executors, right? Or partition. So here again one write exchange is created and all the data is sent to write exchange. And this stage will end here. And in the stage 4, you can see it will read the data from previous write exchange. And after that, it will perform the two partitions, and it will perform the operations count operation on the two partitions, okay. And after that, your driver will collect the data with the help of the collect method. So this is how your like whole thing is calculated, right? So you can see here we have different types of operations like file scan RDD, map partition RDD, SQL RDD, and all. So let's see and let's dive deep into the actual directed acyclic graphs of our this application, right? So let's see. And yeah, so you can see this is our application, right? So this is the first job, that is job 0. If I open this job, you can see here it scan the text, right? So it scans our data, then it will apply this whole stage collage in this specific transformations, okay, and then after it will apply map transformation on it. So you can see it will read the some partition of the data. So input is 64 like kilobytes, you can see. From that it will analyze the data and it will infer the schema of the data, okay. And if I go and if I see the second job, so now you can see in the stage it will scan the file, right? So but now here you can see whole 761 kilobytes of data is scanned, means whole data is scanned, right? And after that the data is scanned, you can see this is a deserialized is here. So in this stage it actually apply the or infer the schema of the data, and after that it will do the transformation on that, and it will creates a data frame, right? So this is the second stage of your job, right? And after that, let's see, you can go in the deep. So here you can see file scan RDD. This is the very low level abstraction APIs of the or Spark core APIs. You can see this is the file scan RDD that will scan or reads the file, then map partition RDD. It will apply all kind of map partitions in your RDD or data frame. Those partitions like map things are like any functions that are applied on individual rows of your data, okay. And here like some SQL partitions, SQL also or methods are also applied, so that will execute multiple queries at once, okay. And the whole stage partitions are also there. So let's see our third job, okay. So we have analyzed these two jobs, right? So this is our third job. So you can see in our third job, as we discussed, it reads the data from previous file, okay. So here every dot indicates one transformation, and you can see this arrows indicates a kind of like moving the data from different transformations, okay. So after that you can see whole stage this kind of method is applied here. So actually in this method if you dig deep, so it is repartitioning of your our data, okay. So it creates the two partition after reading the data, and it will store the data in this exchange or write exchange, right? So here you can see from this stage, as the stage 2 is completed, your data is read from this write exchange, read to read exchange. And after that whole stage like collage, it has all the things applied on your data, and it executes the applications or like transformations in parallel, like with columns, select, etc., etc., that we saw. And after the performing that, when it hits the group by, that is white transformation, you can see it stored those things at the exchange, and our data is reshuffled at the exchange, and from the exchange in the stage 4 the data is again read, again the narrow transformations are applied here, and after that the data is again collected by your driver, okay. So this is how your like directed acyclic graph you can analyze or see your directed acyclic graphs, right? And let's see in the stages tag, you can see all your stages are there, right? So you can see in the first job itself, job 0, stage 0, you can see here it has only one task, okay. And here you can see 64 kilobytes of data is needed for inferring the schema or for calculating the schema of your data. Then after that in the stage 2 you can see input is around this much, that is 761 kilobytes. So it is our whole data it is reading after that in this second job or second stage. After that in our in our second job you can see this is again one stage is there, right? That is our third stage, and it reads the data, right? And it repartitions the data, so it writes the data in the two partitions in the buffer. So this is, you can see, near around half of this read, right? So it has two partitions, right? So this data is written to the exchange, right? Exchange, right? So into 2 you will get this number. After that in the further stage, that is the all transformation that we run, okay. So here you can see two tasks were there. So here two parallel tasks were executed, and those two parallel tasks reads or shuffle reads like this much data they read, okay. And they write the data in the shuffle write, okay. and this much data that those two tasks writes. And after that, in the last stage, you can see again the shuffle read was happen, and after that the data is collected by your executor. By just clicking on any of this, you can go in the details of the application. So this is our fourth stage. Okay, so you can see here in the stage 3, or actually fourth stage if you count from 1, you can see it is reading the data from exchange. You can see shuffle partitions, it is reading the data, right? Then after that it is performing these transformations, and it includes all your transformations that we apply, like select, etc, etc. This is map partition RDD, right? So map partition, this all are narrow transformation that we apply, and it is giving this to the exchange. And if you see here, the task informations are here, right? You can see all the task informations that are available. So this is how you can dive deep into your Spark applications, okay, or Spark WebUI. Now I am, and here you can see I have mentioned all this operation that we frequently encounter in our directed acyclic graph. So you can go through that, okay. So now main question is that what is this Spark 2.x versus Spark 3.x, okay. So the here thing is, in Spark 2.x or Spark 2.0 versions, a new job is created every time an action is called, right? That we studied before, such like collect, count, show, etc., etc., right? But because of the Spark 2.x uses concept called Spark 3.x, sorry, 2.x uses the concept called lazy evaluation, where actual computation is triggered after an action is called, right? But Spark developers or the team who is developing and maintaining the Spark, they change some things or change job creation strategy in Spark 3. So in Spark 3, the job creation mechanism had changed. In Spark 3, they introduced a new concept called adaptive query execution or AQE. With the help of AQE, Spark 3.0 dynamically adjusts the query plan based on the runtime statistics. Okay, so what exactly they do? In Spark 3.0, job is created on a checkpoint basis. When a checkpoint is reached or specific checkpoint is reached, rather than the action is called, a checkpoint is a point where query plan uh, can read the data or can easily start the execution if something fails from that point. So it will create a job based on that, okay. So you can see here it can safely pause and resume the execution. It will create a job based on that. This allows the Spark optimize the query plan and reduces the number of the jobs that are created. So in summary, we can say in Spark 3.0, jobs were created based on the checkpoint reached level. Okay. So let's see practically how this thing works in actual. So in our Spark application, for enabling this, we have to comment this specific configuration, that is enable adaptive query, right? So I will restart the whole thing, and let's clear the output and let's run all. So I will close this Spark WebUI and we will reopen our WebUI. So you can see now I have commented this in our Spark configurations. Okay. So you can see Spark session is created and now it is executing our job that we have created. Okay, so let's wait until it execute, and you can see we got our result, right? Like this employee and all. So let's go to our Spark UI. So this is our Spark UI. Now, if I go to jobs tag, you can see previously we have 3 jobs, right? But now you can see we have 5 jobs are created. This per job is usually inferring the schema, then this job is reading the job, and after that it creates the job for different things, okay. So if you see the third job, okay, it scans the data, runs the partition and exchange. So this job is created after the repartition. So repartitioning thing will also create one job, okay. If I go back again and if I open the job number 3, okay, so you can see it is reading the data. So here the things are paused, and you can see this stage is like one thing is skipped, right? So, and after that, you can see the completed stage is 1 and skip stage is 1. So this stage is skip stage. As per the Spark 2.0, this stage is also part of this job, but in Spark 3.0, this is skipped, right? And it can easily read the data or it can pause at any time. So this is our all transformation thing, right? Select, filter, whatever we have done. And if we see again here, in the last, so you can see all these things. So here it shows it uses the data from previous stages, but it skips those stages, and this job is created only for that count operation after like one narrow wide transformation. Okay, so you can see here it creates only one task after that. So this is the way that Spark Adaptive Query Optimization works in Spark 3.0 and above. We will see in detail about all those things when we will dive deep into the Spark optimizations and all. But for now, this is how your Spark application works and how all your web UI works. Okay, so I am uncommenting this, and yeah, I will provide you this code as well. So for this is the whole Spark Web UI and how you can analyze and read the application, okay, and understand the application. If you feel any questions or if you have any questions, then feel free to ask the questions in the comment section below. I will try to answer all your questions. And please support me. I will provide you this kind of in-depth content. So please follow me on YouTube. Yeah, and thank you. Happy learning.